here and they can have evidence.
A little bit of background.
Yeah. Okay. So we're live.
All right. So I think this week it was good. It was a little more difficult with like functions, kind of different. And then going into limits at the end of the week here.
Yeah. You've taken before.
Right. So like limits they're not hard. It's just remembering how to do them.
Yeah, the basic limits. I actually got my Friday and Monday homework done like at Tuesday because I'm like, oh yeah, I remember these, and just and just plugged in all my limits real quick. I guess for me this week the harder thing was probably the crap, what am I thinking about? Just memorizing the
like the integral
all
and derivatives of the
yeah,
transformations.
because there's so many ways you can change it around. I know one of them I was kind of struggling with, so I was trying to remember how you change it. Because you have your A's and your C's and all your other letters you want. I know one that was killing me was tangent, hyperbolic tangent, because it goes from a squared plus u squared times x squared, and it goes to like u over a within hyperbolic tangent for like an integral or something like that. I forget. There's so many moving parts.
Right. Yeah.
But other than that, my normal nemesis is still my normal nemesis.
Mine too.
Finding those initial value problems and the it's just the word problems that kill me. Because I'm like, I don't even know what I'm looking at.
That's what killed me on the quiz was we had a couple of those and I was like, oh man. What am I
think those were the two I bailed on. Yeah.
Yeah, it's trying to organize the different parts of the word problem to look like an equation, like a normal problem. That's what gets me.
Yeah. Sometimes I notice I struggle though, because even if I have the parts, one that was killing me was the related rates was killing me, because I could remember how to set up a related rate problem. Because like I got to the triangle, and it's like, okay, well I have this rate and I have this rate. It's like I got the positions of all the triangle, like all the lengths, and I had one related rate, but I had no idea how to get that related rate on this spot. It's like how was it? It's like I had the hypotenuse related rate, but I needed the opposite related rate. So I just put in some numbers. I was like, well, what did I even do? I think I like used the arctangent and something. I don't even know what I did. I think I got it wrong, but I guessed, and I showed my work, and so I'm hoping I get work points.
That'd be good.
I don't know. But anyway, yeah, I struggle with those. So.
Yeah, I do too. I'll be honest with you. So add on too.
Yeah. So, do you want to study anything here in particular, or?
I was just looking over again our assignment Friday and the activity. It was on we had two different ones.
Okay.
There was using Wolfram Alpha.
Mm-hmm.
And to explore limits and tables with graphs. And so basically it just kind of gives you the equation and then you plot it in at Wolfram Alpha. And then you could it gives you different zoom periods to zoom into.
Right.
Basically how the graph looks like it'll flatten out at some point the farther in you zoom. And so it was kind of doing a little bit of that. And then in Excel, it just gives you numbers It doesn't show you like a graph. It just gives you numbers.
Gotcha. Yeah,
Just kind of
I
looking
do
at
remember
those.
that one.
And then the other assignment was the limit rules,
Mhm.
where it just gives you like x approaches 1 of f of x equals -5.
Yeah.
And the limit as x approaches 1 of g of x equals 4. And then it says, like the problem 1 is the limit as x approaches 1 of -3 times f of x.
Right.
So
I don't think I had any problems with that because like -3 times f of x is just you take f of x times by -3.
it's negative.
And I remember, like I remember if you remember these, but there was like, I'm just gonna type in an equation real quick here on the bottom of or on the side of your page. I don't know if you can see that. But it's like, that equation there, I know. Like, okay, so there is no limit at x minus 5. So at 5, there is no limit. There's a gap, right? Or no, there's no number, but there's a limit at 5, right? And that's like ones we weren't doing that this week though, were we?
Where did you type that message at?
There's a little group chat bar. Do you have that?
I have that not right here.
Are you on your phone?
Yeah.
Oh, okay, that's probably why.
I'm on the message now for today where you like it shows the outgoing call. And then I can start having a conversation with you. Here. Did you get that? I sent you one.
My phone got one, but this group chat doesn't have one. Oh well. It'll still work though. Yeah, I saw it. It said "Hey" on it. Okay, well, I can just tell you. It might be quicker then. But it's like x plus 5 times x minus 3 over x minus 5. There is a gap at 5, but you want to find the limit. I remember we're going to be doing that soon. But one thing I was trying to remember though is that if the two sides don't match, is there a limit? Because you can have a limit from the left side or a limit from the right side. But if those limits don't hit, is there a limit there? I thought that means there's no limit, right?
No, that means there's no limit. There's a hole.
Okay, because it's like, have like on the ones that we had, it was like x started out 0, and then it went up to 1, but then it just drops back down to here, like half or whatever. And so coming from this side, it was 1. Coming from this side, it was like 0.5. So that's no limit. And if there's just a gap on the right side.
So there is a limit there. Because if you're coming from the right, like if it says the limit as x approaches 1 with a plus sign, be from the positive side, going towards the negative side. And you follow like in your example there where it was like x is at 0 and it goes up to 1. So from 0 to 1, as x approaches, that 1 mark.
Yeah, from the left side, there's a limit, right?
From the left. So if you're going from 0 to -1.
From 0 to 1, there's a limit approaching from the left-hand side to the right-hand side, right?
Right. And then it would drop down to a half and towards the right.
Right, and so there's also a limit from the right approaching to the left, or from the positive to the negative. There is a limit.
It depends. If there's a hole in the
right,
because like in that case where they're both on that line, that vertical line, one of them will be a limit and one of them will have a hole.
No. One. I think one of them. They both have limits, but one has the answer. Isn't that right? That was as I understood it. A limit doesn't care if it's actually if it equals that number or not.
Okay, that's right. Yeah. So approaching from the left, going towards the right, it would be at 1, but approaching from the right, going towards the left,
Be
it
half.
would be a dash. But the answer to the function of the limit would be at 1 if that's where there was no hole.
Right. And you can have the spot be way up high, right?
Yeah, it could not even be on either line. It could just be a dot.
Yeah, like in the homework we had, they had that happen where there was one where approach from here and approach from here, and there's like at 5 they had a little dot, so the answer was 5, but the
Right.
limit from the left was like 2, and the limit from the right was 1. But
Right.
so we know that there is a limit from the left, there's a limit from the right, there's an answer in the center, but if they are different, if you want the general limit, it says no limit, right? Did I understand that correctly? I can type you in the equation. I'll send you a text real quick.
You can send it in that where I sent you, hey, you can send it there. I'll get it.
Yeah, I'm gonna send it there real quick.
Okay.
So it's the limit x from the -1. So it's like I send this, it's like x, so the limit at 1 from the left-hand side. Did you get that?
So it's the limit as x approaches -1.
Oh, sorry, let me see if I can,
1 from the negative side.
yeah, from the negative side. I can't do a sub base in this text here.
No, that's fine. So as the limit as x approaches 1 from the negative side.
Yeah, so now sub base 1. I don't know if that makes any more sense.
Yeah.
But yeah, so it's like as it approaches from the left-hand side, so like the one we were talking about, from the left-hand side it approaches 1. But if I were to say the limit of x from the positive subbase 1, that would be 1/2. But if they wanted the limit of x at 1 without subbase,
It would be. Wouldn't that just be where the dot is?
I don't think so. If I remember correctly, I believe there's no limit. It doesn't care where the dot is because the limit isn't caring about what x is. It's just that what x seems to be becoming, as I understand it. Because also, you can have two that hit each other, but the dot's way up here, right? So you have, x approaches 2 from this side, and x is also approaching 2 from this side, but they're not, a straight line. They're going this way, but the dot can be down here. The limit is still this point, even though x is actually down here. Is that right? That sounds right to me.
And there's a hole where those 2 points come together?
Yeah, but the limit is still there, right?
The limit as it approaches from the left side and the limit as it approaches from the right side are both there, but the limit at that number.
No, the number isn't there, but the limit from the left and from the right is there.
But the limit
number is there. There's a hole there.
Right.
Yeah.
So the limit at that number is like the limit of x of 1 at that number, not approaching from the left and not approaching from the right, at that number would be no limit. Is that what you're saying?
If they both hit the same number, there is a limit. If they don't hit the same number, there's no limit because they don't equal the same.
Okay.
So I believe that's correct. I wanted to check with you. I wasn't sure if you'd read it up, but that's what I had remembered from past classes. And like, okay, so I'm sending you an equation right now. So as I understood it, this one, there's a gap at 5 at this equation I just sent you. Do you see it? Because it's on the denominator, you can't have it at 5, so there's going to be a hole there. But we can still find the limit at that point. And that's the glory of limits, is that you can find the answer even though there isn't a number there. Right?
Yep, that's right.
Okay. And so, basing my knowledge off that, I just want to double check. So if it ends at some point, so x keeps going, and then it stops. There's nothing else past that point. Is there a limit at this point? Because there is a limit going all this way. The number could even exist this place, but it just doesn't exist over here. Is there a limit here? Because there's nothing on the right side. Because I know there's one approaching from the left. So there's limits, the limit of subbase of 1 approaching from the left, or subbase of negative or whatever.
Right.
There is one, but I want on the right on the homework. I didn't see that. I didn't really check my answers, though. I was pretty confident on them. Probably should have done that.
I don't know. That's I don't remember.
Okay. Have to get on that then, I guess. But okay.
So explain
That
this
was-
to me.
What was that?
I said explain this to me. So like on the assignment,
Mhm.
struggle a little bit remembering this.
Okay.
On not the assignment, the activity.
Okay.
Number one says the limit
Okay.
as x approaches 1,
Okay.
-3 times f of x. Of f of x is -5. So I would just do -3 times -5, and that would be my answer.
I think so. I think that's right. So let me see. Of f of x and f of x all right, is that right here for you?
Yeah, and so this is the equation here. When the limit of f of x is -5.
So you want the limit at 1.
As x approaches 1 of -3 times f of x.
Huh.
It's -5.
So you already know the limit is -5.
I already know that the limit of f of x is -5
At what number?
as x approaches 1.
Okay. I'm what I was assuming before is that you would just multiply by -3. That makes sense to me. I mean, how the equation's spelled, it's a little finicky and it leaves room for interpretation, which I hate. But if you're just to say, okay, f of x is the limit at 1, which equals -5, and you want to multiply that limit by -3, it would be 15. Yeah, that makes sense to me. And that's what I believe I put in my homework as well.
Isn't there like a
Answer key?
a constant multiple rule or something to do like that with limits?
You're probably right.
Where like in this case, you could pull out the -3 out front, and it'd be like -3 times the limit as x approaches 1 of f of x, which we know is
I think you're-
-5. So then it would be -3 times -5.
Yeah, I think you are right. Is this activity A or B, by the way?
This is B.
B. Okay, I'm pulling up the answer key right quick. That might help us out a little if we just have the answer key, right? Okay. Oh yeah. So the limit of so what the equation says is the limit, and then a parentheses -3 times f of x when x approaches 1. And they had a constant multiple rule where they did -3 times limit f of x as x approaches 1. So yeah, she actually pulled it out right in front, just like your constant multiple rule, and that gave you 15. So you were right in that case.
So then on number 2, can you kind of do the same thing, except it's like, wouldn't you have to add the limit to be like the limit of 2f of x plus the limit of g of x?
You can
and then
you can take the limits separately. So you can make it as the limit of 2 f of x plus the limit of g of x. And you can pull that 2 out in front, so you can do 2 times the limit of f of x as x approaches 1 plus
Which
the
would
limit
be
of g of x as
like 2 times -5 plus 4.
2 times -5 plus 4. Yeah, giving you -6. Yeah, that's the answer they get here too. Yeah, because I'm looking at it right here. And I think this is actually exactly what I was thinking, as same as you. So they are very similar. When you take the limit, you can do them separately. On 4, you see they have a big square root on top of them. So you have to stick the limits inside them, which was interesting because they have the limit of the square root of g of x minus f of x, right?
Okay.
Fortunately, it looks like you don't have to square it or do anything funky. They just have you take the limit of g of x inside that square root. Does that make any sense?
So you take like the limit of g of x, subtract the limit of f of x, and all of that's under the square root.
Bingo. That's what she has shown here.
You really like 4 minus a -5, so it's really 4 plus 5, which is 9. You can find the square root of that, so the answer would be 3.
Exactly. That's what she's getting here. So.
Okay. So what about like on number 3, where you have a denominator and you have a numerator?
Denominator.
Like,
oh, that's interesting.
On the top, you would have like the limit of 2 minus f of x. And then on the bottom, you'd have the limit of 1 minus 4g of x.
Yeah. This one's actually the interesting one. So she has, you can do the limit separately, but that's what's interesting is that on the top, it has the limit of 2 as x approaches 1 minus the limit of f of x as x approaches 1 over the limit of 1 as x approaches 1 minus 4 times the limit of g of x as x approaches 1. So apparently you take the limit.
The limit of a constant is just the constant, right?
Bingo. Yeah. So the limit of 2 and the limit of 1 is just 2 and 1 respectively.
Okay.
And then the limit of f of x was -5 again. So 2 minus -5 is 7. Right. And then you have 1 minus 4 times 4. So you have 1 minus 16.
Be -7/15.
Yeah, -7/15. That's right. That's interesting though, because I didn't realize that you could take the limit of 2 as 2 approaches 1, but then again, they're just looking at like what y equals 2 basically, and so it's never going to change because it's a constant, right?
Right.
So I guess that makes sense. That's a good thing to know though. I never would have guessed you could take the limit at 2 or the limit at 1. I would have thought you had to do something funky to it.
So then, like on number 5, you would do the same thing that you did like on number 4, except when you get down to the end, you'd have to find the cube root of the number rather than just the square root.
Right. Fortunately, though, the 2 times the limit of x equals 2, and 2 times the limit of f of x equals 2 times -10, which actually equals 8, which cube roots nicely into 2.
Let me ask you this: so I was looking at the limit of 2x. So you get the limit of x, but what is the limit of x as x approaches 1? Is it just 1?
The limit of x as x approaches. That's what's showing. So it says 2 times the limit of x as x approaches 1. It has showing as 1 in the homework.
And is that as x approaches 1? So if it said like 2, or if it was like the limit of 2x as x approaches 3, would it be
6?
Like 2 times 3, basically?
I think so. I think you're right. Because I mean, what's nice if you notice is like is the limit of x as x approaches 1. Well, if you're trying to find x approaching something, it's probably going to be that number. Maybe just me thinking, because normally f of x or g of x is a y function, but since you're plugging in an x function for an x, it just simply is that number. Does that make sense?
Yeah.
So, because like if you're plugging in a y function, that was going to be different. But since x is basically the same function, you're just going to get the same number as it spits out. But if it has like a multiplier on it, like 2x, you're just going to constant multiply it. I'm not sure though what you do if it's a square though. Like
You
did I
there?
lose you?
I can hear you. Can you hear me?
Yeah, I hear you. It said on my phone you're trying to call me. Oh,
I don't know. I lost you somewhere.
okay, that's really weird. Because this call on my phone is still going on. Oh.
You still there?
There we go. Sorry, I had two calls with you going on at the same time, and I was getting some crazy feedback. So did that make any sense to you?
Yeah, it did. Are we still live?
We're still broadcasting, yeah.
Oh, okay. So,
Even though you left, I was in charge, so it all
well,
worked.
I didn't leave. It just stopped.
It stopped on you?
Yeah, I just it's like kind of like a call dropped. Like you ran out of service,
Oh, weird.
but I didn't run out of internet.
I know, I didn't either. I just saw you're calling me all of a sudden. I'm like, where'd you go? And then you connected back in. So I don't know.
Huh.
But
I
no, it
just
still says it's working.
Okay. Well, I can only see your icon now. I can't really see your face or anything. I just see your little picture.
Not really. It's showing my face. Maybe my internet got worse. I'm surprised it is because literally my laptop is like 12 inches from the Wi-Fi. Like right now, it's just like right there. So you'd figure I have good service right here. Just saying.
But
I would.
But anyway, no, that makes a lot of sense what we were talking about there.
Mm-hmm.
So that helps me understand that a little better.
Gotcha, good. And then that helped me figure it out because as I'm explaining to you, I'm like, oh yeah, that does make sense to me. Gotta love that, right? But okay. Well, I think that's some good work we've had for the day. Anything else that you need help with or whatnot?
I don't think so. I think that's pretty much it. What about you?
I'm still struggling with my related rates. It is what it is.
I am too. I've come to the knowledge that maybe I don't need to understand them all. If I do well on everything else, I don't have to always understand everything.
Right. I'm actually thinking of doing on Wednesday. Doesn't the teacher have? Well, I don't want to take. Do you go to the Wednesday time meeting the teacher has had from the beginning? The teacher hours forgot existed.
No.
Okay, because they
Didn't
have
even
a
know
teacher meeting
today.
every week. I know she has available, and I haven't been on since the first week. She gave us credit for doing it one time within the first 3 weeks. Or is that my physics class? Am I going crazy?
I don't think that's this class.
All
Maybe
right. My wife just told me it's from the other class, so I am going crazy.
No, it's all good.
I'm thinking of just meeting with the tutor online and just trying to really just hash out these related rates and these other ones. I don't know if you want to do the same thing, but I'm seeing if we can do that next Friday, and maybe we could actually get her on to this, and she could help us. Do you think? Because you're struggling with the same thing I am.
Yeah, we could talk to the TA and see if she's available or whatever.
Okay, because I was thinking of doing it Friday. Do you take the tests? You don't usually take the test on Saturday, though, do you?
Oh, it just depends on if I'm gonna be around that weekend or not.
Gotcha. Because I usually take them on Saturday, so I was figuring we could meet with her on Friday and be like, okay, hey, how in the world do I get these related rate problems? And if we could figure out those ones, I think that would get me in good shape. Because other than them, I do pretty good with my homework. It's just the only ones I really skip are those because I just don't get them.
Yeah.
Something to think about. Food for thought, right?
Right.
But yeah, other than that, I'm doing pretty good. Sounds like you're doing all right. I'm looking forward to related rates, to be honest. So, or not related rates. Limits. They should be fun.
Limit. It should be.
But yeah. Well, I guess we'll end this now. But I hope you had fun.
Yeah. We'll try to get with the TA. Are you gonna contact her then?
Yeah, I'll contact her, and now my wife can hear me, so she'll remind me and be like, "Hey, you're gonna let down your teammate. You better do that." So,
Right. Good. And just
All right.
let me know. We can figure something out. I think we're gonna stay at home next weekend, so I might not take the test till Saturday. But
Gotcha. So I think that would help if we talk to her. Because also last exam, I thought they were gonna do all these trig functions, and there wasn't a single one on the test. Was
I
there?
know.
I was so
It
ticked.
might have been.
Okay, I wasn't ticked, but I did all the studying to figure out the trig functions, and there wasn't. I didn't remember seeing one on the test, and instead there was tons of. What were those problems? There's all the application problems, and I was like, I'm sunk because I did all the studying for the wrong stuff.
Yeah.
Oh well. Anyway, I vented. So, but I'll send you the connection for this. The link.
All right. Sounds good.
All right. Talk to you later.
We'll talk to you later, man.
All right.
Bye.